All right, welcome everybody. Week 16, day 2. It is a day before Turkey Day. So, we are pretty much at the end of the semester. Next week is the last week of instruction. The week after that is week 18. All you're going to have to do on week 18 is competency exams. We're kind of rolling through the end of those right now, but you do get up to 4 retakes on each one, so it will be rolling through. Finals week shouldn't be too big a deal. Be on the lookout for new competency exams coming out. The homework assignment, we'll go over that first, and then we're going to talk a little bit more about linked lists. And then for the last week of school for this class, I typically do a thing where I just allow students to vote on what topics they want to learn about. And so the previous class said they wanted to learn about Java, so we'll probably do a little bit of Java. If you guys have any topics you want to learn about, let me know. And especially if you're only going to have me for this one semester, because I have a lot of math majors and things like that that only have to take a semester of computer science, not knowing that they're actually going to need it by their senior year. And so I can talk about how to use Unix. I can talk about security. I can talk about networking. There's a lot of things you can learn about in computer science. And sort of the last week, I typically just take requests for different things. So MATLAB or R, I can't help you with that. I helped a student learn R 2 years ago, but yeah, I don't know it well enough. I've done MATLAB also, and it's not something that I would feel enough of an expert on to teach, unfortunately. So they're both useful and cool. Python, you can do Python as well. It's pretty easy. So let's talk about bridges, Shakespeare, and then you can put up your suggestions in the chat. So the neat thing about bridges is that it'll visualize your data structure. So they have a singly linked list called SL element, and it holds strings. In this case, it's holding the name of the word, the name of the word that holds the word Hamlet, that, king, whatever. And by default, the list is empty. Null pointer means it's pointing at nothing. And cur is, sometimes I'll call these things head and tail. This is the head of the list. This is the tail of the list. Terminology thing, it doesn't really matter. So if you try running your program and you get nothing, well, first of all, make sure that you've got your API key, you've got your username typed in. If you don't have those typed in, it'll give you a bridges error, like you need to enter your credentials. But let's say you do that and you run the code and nothing appears on the screen. If root is empty, if root is null pointer, then when you try setting the data structure to be rendered to be root and visualizing it, it'll draw nothing on the screen. If you have only one element in it, which is a lot more likely, then what's happening is that you haven't done these 2 lines of code yet. So it's really hard for students to visualize a lot of times what's happening when you're doing linked lists. And bridges visualize it, so you can kind of see what's happening. So if you're not, let's say you're making an SL element for each word in the top 30. If you're not linking them together, then they won't appear when you visualize the root. It'll just show the root, and if there's no next hooked up, it'll just show the root. And so that's a sign that you're not doing your pointers correctly. So what you need to do is these 2 lines here. So every time, so when you start off, root's empty. It's pointing to null. So if root is null, then I've already done this code for you. So if root is null, then it sets root to be the new guy, and tail to be the head and tail, root and cur, are set to point to the current guy. The next word through, it's going to a new list, and what you have to do is have the last element in the old list point to the new guy, and you do that using the setNext function. So you're going to have to say cur points to setNext, and you're going to pass it the new guy temp. Okay, and then you have to have cur point to the last guy. And if you do that properly, if you get these 2 lines of code down, then when you do the visualization, it'll go bloop, 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 and everything will work fine, and you'll be good to go. Okay. So That's basically the level of linked list I require from first semester computer science students. Any questions about that? You cannot get the syntax properly? Look at examples of set next, maybe. It's a function. Set next is a function call. You pass temp to it. Yep. It's not just a variable like this. You pass temp to the function called set next. Okay. So, any other questions? Posted on chat. Current points set next temp. That's actually exactly what you should be doing. So, screenshot it. There's probably, I don't know if you're forgetting a semicolon or something, but that's the proper syntax. So let's say we've got our super basic linked list class here. Do you need constructors for the assignment? You can't get yours to work. Candidate expects 2 arguments, 0 provided. So the problem is you made a 2-parameter constructor, but you don't have a 0-parameter constructor now. So once you start making constructors, you got to make constructors. It's just how it is. So do that. Let's make it a 0-parameter constructor, and candidate no known conversion from const word to int. So that's what your problem is. So you're trying to pass a word here to it, and it's not a word. It takes an int as a parameter. So what line of code is that? Error message. Anytime you see something like this, it's just like, cool, good job, C++. I love C++ error messages. They're fantastic. So no matching function call. What line of code is it? C++ main CC line 20 maybe? 22. All right, let's just see where you're making a word. Somewhere you've got, you're passing a word here instead of an integer. That's the problem. Okay, can't do that. You can't make a word out of a word. So somewhere within your code, you're trying to create a word, passing another word to it. String word, histogram. Histogram.count equals 1, count plus plus. That looks fine to me. So yeah, that's the problem right here. So you're getting, so for every element in your hash table, you're getting a string, which is the key, and you're getting a word, which is the value. And then you're passing that as the second parameter to create a new word. It doesn't take that, it takes an int. So you want to say .second.count. There you go. So that's how you do. The error message, learning to decipher error messages in C++ is a bit of an art, because C++ famously has some of the worst error messages you've ever seen in your life, because none of that was helpful, you know. So you have to look at it and try and figure out what it's actually trying to say. And what it's trying to say is, I don't know how to convert from a word to an int. That's all it's trying to say, because your constructor takes an int, you're passing it a word, it doesn't know how to convert between the two. So the problem is you wanted to pass in the count of the word, not the word itself. And so I just changed p.second to p.second.count, and then everything works fine. Yeah, Shook, you have to do that, but you also have to set current equal to temp. Okay, so what you're doing right now, Shook, is this. So let's say we have an empty linked list. You create a new one. Hamlet 485 or whatever, and then null. So what your code is doing right now is you're saying, here, let me put it up so people streaming at home can see it. So right now, I just did this, right? Root, let's actually snap it over to the side here. Snap this over to the side here. Okay, so this is temp right now. We just created a new node. This is temp. And then we're saying root equals temp. Okay, root equals temp. So root's pointing at it. Current equals root. So current's also pointing at it. Now, second node getting added, we're making a new one. So the new one is going to be, I don't know, king or something like that. King, the count of 400, and it's pointing at null also. And then what we want is for Hamlet's next to point to king. And you're doing that right now with this. So current, who's the last in the list, the last in line, like Dio says. Current's next gets set to be temp. So cool. Temp is currently put in here. Second time through. Temp's always the new guy. But what has to change is this here. So cur is the last. It indicates the last in line, and currently you're not moving it. So if we insert somebody new, if we get to the third one, what's going to happen is we're going to make a new one holding Ophelia or something with a count of 300, whose next is null. And temp would be pointing her right after we knew her. And your code is going to say cur points to next equals temp. And so what it's going to do, it's going to have it pointing this way, and then this guy is going to vanish from reality. There's going to be no way of getting at this one anymore. And the reason why your code's not working is because you're not moving cur. Every time you add something, cur needs to move to the end of the line. Okay. So what you have to do is not only say current points to next equals temp, but you also have to move cur to point to the end of the line, because root is the head and cur is the tail. So every time you add something to the end of a linked list, you have to move the end of the linked list down also. So you have to do both hooking up the new guy to the end of the list, and you have to set the end of the list to be the new guy. Okay? And you have to do that after. Don't do it before, or everything's going to break. Yep. Don't delete cur. Don't do that. Temp. This by itself does nothing. If you just say temp, this doesn't do anything. And delete cur is absolutely bad. You don't want to be deleting anything in this assignment. So you want to do cur points to set next, then you want to set cur equal to temp, and your code will work fine. Okay. All right, so let's go and look at some linked lists. So I just built a little linked list by hand here. I make list A. Let's see if I can come over here and kind of snap it over. Can I hide sidebar? There we go. Okay. So let's do this one line at a time. Okay. So I've got here, let's say we run the first line of code. We run this line of code. What happens? It's going to allocate a new block of memory like this. And inside of it, it's going to have an integer. This is just a linked list of integers. It's going to hold the value of 10, and its next is going to be pointing at null. Or we can draw it. We can draw it as pointing at null. Either way, null's 0. So it just has the number 0 in it, really. And so A is pointing at this chunk of memory. So we got a pointer called A, and it's pointing at the chunk of memory right here. Okay, now we run the next line of code. And the next line of code runs. It allocates another chunk of memory, which we're going to call B. B's next is set to A. There. And then we run the third line of code, and this is somebody named B. B's here. And then we're going to create a chunk called C, and C is going to hold 30, and its next is pointing at B. So this is a linked list. So C is the head of the list, and A is the tail of the list, or the end of the list. Okay. And so if we wanted to print out this whole list, we would do so by starting at C, and then going to the next, and printing B, and then going to the next, and printing A, and then going to the next, and be like, oh, we're at null. We're done. Okay. So in C++, you can do this recursively. I tend to just use for loops. There's a really nice for loop pattern, which looks like this. For temp equals C, that's the beginning list. As long as temp is not null, temp is equal to temp points to next. Sorry. And then we just see out temp points to X, and we're good to go. 30, 20, 10. All right, it prints out C. It prints out C, goes to the next. That's not null. Prints out B, goes to the next. Prints out A, goes to the next. Oh, that's null. Null is 0. 0 is false. It terminates the list. Good to go. So this pattern here is this is the classic linked list traversal pattern. Okay. Sometimes in computer science, it's good to just kind of like memorize certain ways of doing things, because if you try figuring this out on your own, like you're probably gonna have an off by one error. You're gonna go one too little, one too far, double delete, double use after free. I don't know. So stick to the pattern. You're good to go. It's like a for loop. You know, like you for int equals 0, I is less than 10, I plus plus. How many times does that run? 10 times. Like I don't have to think about it. It's just like just knock it out. And when you have to think about things, you can make mistakes. You know what I mean? So. That's the error I'm getting. You are not building your code with make. This is a linker error, okay? And so in order to compile your code with bridges, you have to link in the curl library. Curl is a way of communicating over the internet easily. They're using libcurl. So what you need to do is type make instead of compile. You'll be good. All right, so when you visualize your bridges Shakespeare, the README file tells you which ones to use. So you're going to need to add in Hamlet, Coriolanus, The Tempest, and Henry VIII. It's kind of a cross-section of a couple different genres and things. So that's what I'm going to be looking for when you do your visualization. Okay, so you do your visualization. You're going to submit on Canvas. You're going to submit the URL for your visualization, and I'm going to look at it and be like, yep, that's correct. And then you get the 3 points. Okay. You can copy those in from the public directory, or you can just access them directly. You can just type /public /Shakespeare /tragedies /Hamlet if you feel like getting carpal tunnel. It's up to you. All right. One thing to mention is, because we are coming up on the end of the semester, is you should back up all of your files. I know I've mentioned this before, but I just want to briefly touch on it again. WinSCP or any SCP client of your choice, you can log in on the server and copy the files to your local machine. The accounts do get wiped at the end of the semester. So if you want to preserve your homeworks and things like that, then back them up. I do retain copies of every submitted homework assignment. And I have that both for my records and because the school mandates it, actually. Anything that's been you have to retain records for like 3 years or something like that. But it's also really useful for students, because like they'll go to Stanford and Stanford's like, hey, we need to figure out if we should give you, which happened 2 days ago. One of my students is at Stanford now, and he asked for the syllabus for CSCI 40, and sometimes they want to see the programming assignments they did, and so I will zip up all of the programming assignments you did and send to you, but I don't have all of the files in your account, just the things that I've collected. So you probably want to back up your stuff. Okay. What should Mac users use? Any SCP client. Just Google for SCP client for Mac. There's plenty of them. It's a very common protocol. All right. And then coloring your thing. If your lists are coming out white and they're not getting colored red, yellow, or green, you're going to need an if statement here, and you're going to need to figure out, I'm not going to tell you, you can look up the documentation, but if you want to change the color to red, you're going to have to change that word there from white to some word. I'm not going to tell you what word, but some word. The hard part of the assignment. If you want it to be yellow, that word white is going to change into some word. I'm not going to tell you what. Okay, you're going to have to guess. Or look at the documentation, one or the other, to make it yellow. Yep. I can't get this to work for adding the words into the histogram. Let's take a look here. For every character in the string, if it's an alpha, you append it to the other string if the size is less than 4. Continue if histogram.contains S2. Yeah, that's wrong right here. So if it contains S2, you are incrementing the count properly, but otherwise you want to just say map S2 equals 1, not dot count. Dot count isn't part of the string. Like that's not. Just map square bracket S2 like this. Map square bracket S2 equals 1. And that'll set the initial count on it. Okay, so yeah, actually let's talk about deleting a little bit. Is in a map of string and words. It depends how you do it. Some people did it between a map of strings and words. Some people did it as a map between strings and ints. It looks like he's doing a map between strings and ints. So either way, dot count wouldn't belong there because that's S2 dot count. S2 is a string. It's not a word. So let's talk about deleting a little bit. We're going to get kind of into CSCI 41 territory where we do more with lists. But let's just show you a little bit about how like pointers can be like doing their pointer business and stuff. So if we wanted to delete B, if we just did this, delete B, B's been deallocated. But the memory has not necessarily been reclaimed. Who knows what will happen? Anyone want to put a bet down? What will this for loop print out if I delete B? B is the middle element in the list. It might still have 20 there. So technically it's undefined behavior. But just put your money down, put your bets down. What do you think it's going to print? 30, 20, 10 still? 30, 0, 1, 20. You're going to bet it's going to still print 20. All right, let's try that. Compile. 30, 0, 1. Why? I don't know. It's undefined behavior. You're printing out unallocated. You're printing out a value that's been unallocated from memory. Who the hell knows what's going to be there, you know? So the fact that this did not cause an error causes people who work at banks and things like that to break out in a cold sweat because, wow, you are, you know, if you're printing somebody's account balance and you're just printing whatever's in RAM there, whoo, that's not good. That's really not good, you know, and that's why the Java language exists. In Java, you can't ever do anything bad ever with memory. Can't go out of bounds, can't use something after you've deleted it. The Java system goes, no, and it kills you. And nowadays in C++, you have something called Address Sanitizer, ASAN, which you sanitize equals address, which you can activate like this. Address Sanitizer makes C++ kind of as safe as Java, more or less. You know, it's arguably not quite as good, but I've never had it fail on me. And what it does is that when your program runs, it watches every memory address, and if you screw up, if you done goofed, it tells you, hey, you deleted B, and then you're trying to print it out. No. No. It tells you which line of code it was on, and then you can come in here and say vim main.cc line 20, and right there I am accessing some memory that has been deleted. All right, where was it deleted? Well, so that was when I was using it, and freed on line 16. 16, Shift G, there it is. Address Sanitizer is amazing, and whoever whoever made it is a blessed individual. I think it was Google, actually, some engineer at Google that made it. It is fantastic, and it allows C++ to be really as safe as Java, and kind of takes away the raison d'etre of Java, because the whole point of Java is that it's a safe language, right? You can't go out of bounds. And with Address Sanitizer, if you say int r100, initialize it to 0, everything is initialized to 0. If I cout r100, what is this going to print to the screen? Shook, it's probably because you're passing in a word as the second parameter instead of the count of the word. So try adding a dot count. So p.second dot count. If you're doing it that way. We showed two different ways of doing it. One with a histogram between strings and words, one with a histogram between strings and ints. And so if you're passing in a word when it's expecting an int, it won't work. Okay. 0. Printing out 0. No, Address Sanitizer will not allow it. Why? Why? What's wrong with this? Does element 100 exist? Is it part of the array? If you make an array of size 100, you get elements 0 to what? What elements actually exist in that array there? 99. Yeah. 100's out of bounds. Very, very common mistake. And again, one of the reasons why Java exists is because time has proven that humans are really, really bad at doing bounds checking. And even like professionals, like who made things like bind and things like this, who are the best, geekiest, most talented individuals in the world, every 3 months there was another out of bounds error found, which was compromising security. If you have a web browser or a web server, that's running with root privileges, and there's a buffer overflow exploit for it, which means it's going out of bounds in an array, then what they do is they put a ton of zeros in there. They move down from the stack into the code segment, and they put assembly code, essentially, into the code segment, and they overwrite your code segment with their code. And then when your code returns from a function, it executes their code. And what does their code do? It creates a new account on the system with root privileges with this username, this password, opens up the port, and then the hacker comes in and takes over your computer. That's how dangerous not checking your arrays are. And so Java exists because despite smart people saying, well, just don't go out of bounds. Like, this is out of bounds. You shouldn't do that. As it turns out, people go out of bounds all the time. And some things get really, really hard to figure out exactly how big an array you need and to detect the end of the array, and handling it properly and all this kind of stuff gets complicated, especially if you work with strings. In the C programming language, a string is an array of characters with an extra character at the end called the null character to indicate that you're at the end of the string. And so if you're holding Bill needs 5 characters. BILL null. 0 character. ASCII 0. Okay. So that's bad enough, right? So people will make a string of size 4 to hold Bill. Nope, you need 5. That's the null character right here. ASCII 0. It gets even worse when you start concatenating strings together. So if you concatenate Bill and Bill, right, you have an array of size 5, an array of size 5, and you want it to be Bill, 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 then you need how many characters of RAM? You have 4 characters and 4 characters held in an array of size 5, an array of size 5. You want to hold them together. How big does that array have to be? 10? 11? I'm holding Bill, 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 BILL. 9. You have an array of size 5, an array of size 5, you put them together, it's an array of size 9. Why? BILL, BILL, null. Okay? So, yeah. People get it wrong all the time. And so that's why Java exists. So, Yeah, but with Address Sanitizer, you can have safety on par with that of Java. Honestly, Address Sanitizer is pretty amazing. Okay, so the proper way of deleting this, by the way, is before you delete B, then we would say C points to next equals B points to next. Delete B, and we're good to go. Yep. And so what this is doing now is, if we want to delete B, what we were doing before was we were just delete just unallocates the memory. It doesn't do anything else. It doesn't even change what's in RAM a lot of the time. It just unallocates. It marks it as free. This is on the free list now. You can reuse it if you want. It's fine. And so when we printed it out, it was going from here to this, which was now unallocated memory. Who knows what the hell is there now? It's the wilderness. It's the ghostlands. And then we went to some address. It's probably not A anymore. It's some other one, because this pointer is probably wrong too. And you could possibly do what's called a Fandango through core, where you are treating random spots of RAM as memory addresses, jumping there, printing out the value, treating whatever bits are there as another memory address, jumping there, and it'll just bounce around through memory until it hits 0, and then it segfaults. So this is really bad. And so what we want to do instead is set C's next to be A, right? So we set C's next to be A instead of B, and then with just this one little trick that doctors hate, now when we print out the linked list, it will print out uh, 30 and 10. Oh, and we are memory leaking, right? What are we memory leaking? What are we not deallocating? Why do we have memory? But this part's fine. This part's fine here. Okay. What are we? Yeah, we're leaking A and C, right? So we need to delete A and delete C. Okay. There we go. So B is gone. And so in CSCI 41, you're going to become a lot more proficient with this kind of pointer stuff. Having a little bit of experience with it in 40 really will help. Remember, a pointer is just an integer, so it's just holding the memory address of B. It's like 5522 whatever, and B is holding the memory address of A, just like 5529. And so all it's doing is when we say C's next equals B's next, it's going to copy 5529 from B's next into C's next. And so when we go here, then it jumps from C to A. Okay, that's the address of A, C 5529. Or it would actually be divisible by 8, but whatever. You guys understand? And so you kind of have to, anytime you pull something out of a list, you have to kind of clean up the pointers around it. So that, right, so C was pointing at B, now C is pointing at A. Everything's fine. All is right in the world. Okay? Is that too mind exploding? Or is that reasonable? You don't have to delete for your homework assignment, by the way. It's more of a CSCI 41 topic, but I wanted to show you at least a little bit of it. You only do that for sure if you're going to delete B. Yeah. You don't. If you did that without deleting B, it would be gone from the list. But what do you guys expect the Address Sanitizer to say? Memory leak. All right. So it was taken out of the list because the pointers go past it now. But since we didn't delete B, we're leaking the memory for B. We got a new without a delete. Every new must have exactly one delete. All right, so let's talk a little bit of Java. Java is very similar to C++. It's very similar to C++. So you can see we have the function here. Functions are pretty much identical. Okay. We take in an integer, and if it's negative, we're doing like absolute value or something, right? So if they pass in -5, then we return -1 times -5, which is 5. Otherwise, return x. Does this look like C++ to you? This is Java. This is a completely new programming language. Does this look like C++ to you? Pretty similar. All right, I'm going to copy it. And I'm going to paste it into C++ and see out the absolute value of -5. There you go. It's exact. This code I just copied and pasted from a Java program, right? It's the exact same code. Like literally, you can take a lot. Like if you look at the most fundamental foundational parts of C and C++ with for loops, ints, if statements, things like that, functions even, they'll compile just directly, like exactly the same language, with some differences that I'll go into. Now, Java has both integers like this, int, as a primitive type, and it's also got capital I integer like this, which is a class type. So there's actually a class called capital I integer, and the reason why they do that is because classes can have member functions, right? Primitives can't. You can't call 10 dot, toString or like that. That doesn't even make sense, right? It's a primitive. There's nothing. It's just the variable, right? And so they make class versions of each of the primitives, so they can do things like call toString on them or clone to duplicate them or some. There's functionality that they can attach to it, which is kind of nice. So difference. C.out is the same thing as system.out. Okay, so C.out, console out is the same thing as system.out. Okay, that's the difference. So if you're going to do hello world, system.out.println, println adds the end line to the end of it. If you do a print, it doesn't do the end line for you. Okay. So it'll print out hello world to the screen. So there you go. It's a function. It doesn't have the double left arrows, but can you guys see that it's doing the same thing? Integer x equals 10. If x is less than or equal to 10, system.out.println, yo, yo, yo. Else if x is less than 20, system.out.println, yabba dabba do. All right. Otherwise, print Kilroy was here. Does this look pretty damn similar? Yeah, it's the exact same code. Like I said, if you're doing stuff from the core language, not counting the standard library stuff, because C.out's actually not part of the core language, right? It's part of the standard library. Anything in the standard library is pretty, like, there are differences, but you have pretty good odds that it'll just compile in Java. And it's quite deliberately so. They wanted to make it easy for people to take their C++ code and put it in Java. So anything in the standard library has to change because the Java standard library is different. So instead of C.out, it's system out, and you just kind of go through it. Instead of a vector, it's called a vector. Instead of a vector, it's called an array list. Usually we use array lists instead of vectors usually. But they do have a vector class. Yeah. So Java came from 1996 era C++. So prior to modern C++. Prior to modern C++. And so C++ at the time lacked a lot of features we take for granted now, like a string class. Yay, that's cool. String class. C++ didn't have one. Java did. So a lot of these things you see here are actually first in Java and then ported into C++. The vector class in Java, I think, predates the vector class in C++. It's a global array. Doesn't say what year it was made. Yeah, but like Java introduced a lot of features that C++ copied. Same thing in Python. Like Python became popular, so C++ copied some features from Python. Cool. Yeah, for loops. What do you guys think? Is it unfair that I'm asking you to learn a new language day before Thanksgiving? Is this too hard for you to understand? There's silence on Discord right now. How many times is that going to print out a number? Yeah, we could do brain. Yeah, it's going to print out 10 times. So, yeah. Java and Python, C++ used to be the go-to teaching language. And it's still, C and C++ together are sort of still the most popular language in the world. If you can do that. They're not the same language at all, but yeah, if you put them together, they're still the most popular language in the world. But C++ used to be like what was taught on the AP computer science test. It was the standard intro class. You learn C++. But because of the horrific nature of how bad strings were in particular, the university system as a whole nationwide, it's not really a system, but universities nationwide switched to Java, and the AP computer science exam switched to Java around probably 98 or something like that. And then Python came around in 2000, and Python's really easy for beginners. Like, check it out. I'm running Python now. Print hello world. It's actually interactive. Like, you don't have to compile anything. You don't have to save it into a text file. You just like do your Python. All right, x is equal to 10. Cool. Print x 10. Cool. X is equal to x times x. Print x. It's 100 now. Look at this. Ah, cool. X is equal to high. Print x. Wait a second. I thought x was an integer. It was, but it's not now. It's a dynamically typed language, and so the typing of variables can change on a whim, on the fly. And if you think this might cause bugs, it absolutely does. Absolutely 100% positively does. So, it looks easy to use and it's easy to get into, but the type system in C++ is honestly one of the best features of C++. It stops you from doing things like if you have a word and you're trying to put a word into an integer, it doesn't work. And the compiler will tell you it doesn't work. And unfortunately, the compiler tells you, and you have to like hunt through it like, all right, what are you trying to tell me, compiler? Your messages are terrible. They're so terrible. They're horrible. You know, in Python, it'd be like, oh, you want this thing to be a word now? I thought it was an int. Okay, fine, it's a word now. And then your code stops working. You just don't know why. Okay. So, yeah, for I in range 10, print I. Okay. So, built-in auto. Yeah, everything in auto, I think, was inspired by Python. And somewhat sarcastic, somewhat quite serious. I think you just had a lot of Python users who would come into C++ because you learn Python in like first semester computer science and second semester, and then after that they're like, all right, now we're using C++ for everything. And the Python people are like, what is this type system? I don't know. I have a variable, but I don't know what type it should be. So auto just allows you to pretend like there's no type. There's still a type. There's still a type. It just doesn't, it hides the type. Auto x equals hi. What is the type of x? Not string. Hides it. So, yes, that is the voice that people use when they do Python. I'm actually not dogging on Python, believe it or not. I like Python. I like Java too. I'm a lover, not a hater. I like PHP, and people hate PHP because it's a poorly designed language, and it is. But I like it. Like I don't mind writing code in PHP. I like every programming language out there except for JavaScript. It's completely sensible and sane. So Python is useful in a lot of data science stuff. PyTorch, NumPy, Pandas. There's some great support for doing scientific visualization, machine learning, all this kind of stuff in Python, and it's a very easy to pick up language. Like there's nothing wrong with it. Like it's slow, I guess that's wrong with it, but it's easy to write code and it's safe and stuff. So Python's fun to make games in. It's all good. Like people get into these like very tribal conflicts of like C++ is best, Python is best, and it's like, C# is best, and there's pros and cons, like C# has this thing called link, which makes accessing a database really nice. It's got a really nice SQL interface, which is really cool. Python, you can just pick it up and start running it. They got these things called Jupyter notebooks that are web pages that run Python in it. You can click and it'll run the cell, and then the values are held for the next cell down, and so you can kind of interactively do your stuff on a web page. There's a lot of cool stuff. C++'s main advantage is its speed. It's faster than all the other languages because it doesn't do bounds checking, right? And so in C++, I teach you guys to do bounds checking. I turn on Address Sanitizer by default, and I teach you to use .at by default, right? But here's the thing. Once you've got your program finished and you're done, you're like, all right, it's not going into bounds. You can just change that .at into a square bracket, and you can turn off Address Sanitizer, and now your code runs fast. It'll run 2 times faster, 3 times faster, 10 times faster, somewhere in that ballpark. Java, you can't do that. Python, you can't do that. Python has something called Cython where it can compile down, but then you have to start statically typing Python, and it ends up turning into this giant, like Frankenstein monster of a thing. And Java's got some native, C#'s got some native stuff, but basically C++'s main advantage is that it's fast, and that's why people use C++ for game development. C# is used a little bit for game development with the Unity game engine. The Unity game engine is in C#, and then they had to break the C# language. They had to rewrite it and disallow certain parts of it because it was too slow otherwise. And so they actually kind of created their own dialect of C# in order to have it be performant. Like all these language wars are just kind of silly by and large. It's like, if I needed something where I wanted to be absolutely sure that there was no memory corruption and no out of bounds, I'd use Java, maybe Python, because it does it too. So, what's better, hammer or saw? Yeah, it's like, it's kind of silly at a certain point. The only thing that everybody agrees on is that JavaScript sucks. So, it's Mr. Bell here. Yeah, I guess not. You'd hear me casting shade on his language. Where they did a lot of it in C++. Unity. Unity was originally in C++ and they rewrote it in C# so that it's C# from the top to the bottom. And that allowed a lot of optimizations and stuff like that. So let's take a look at this hello world thing here. And so you can see the core language is actually, it's pretty much the same. Making an array is a little bit different. So everything in Java gets newed. So Java loves new. New is everywhere in Java. The only things that aren't newed, and that's not in like naked. No, it's not N-U-D-E. It's nude, right? The only things that aren't newed in Java are primitives. Everything else that you make, even like a box integer, is newed. And you might notice there's no delete, right? There's no delete. There's no. It looks like it's leaking memory, and that's a feature of Java. That's not a bug. Java, the language itself, figures out when something's not needed anymore and deletes it for you. Cool. Everything is nude except for primitives. Primitives are on the stack. Okay. Shows how bad JavaScript is. So an empty array double equals 0. That's true. 0 is the same thing as the tab character. 0 is the same thing as a string 0. So if you use double equal to compare them, but none of these things are equal to each other. So A equals C is true. So a array equals a string. B equals C is true, but A does not equal B. T equals test. T plus equals testing. T equals null. T plus ing becomes nulling. If you append a string to null, it treats it as a string called null. Undefined can be defined. T equals undefined. True. All right. T equals defined. Okay. For T undefined. All right. T equals undefined. False. Wait. What? Does undefined equal undefined? No. 3 dot toString is 3. 3 dot toString not valid. The string 10 minus 3 is 7. The string 10 plus 3 is 103. The string 103. So the string 1 divided by the string 1 is 1. The string 1 times the string 1 is 1. The string 1 plus the string 1 is the string 11. Yeah. Numbers get sorted alphabetically. 0, 1, 10, 2, 3, 8, 9. Yeah. There's a lot of dumb decisions in JavaScript. Okay. All right. So Java. So how does it work? All right. So Java. You compile it using javac. Javac hello world.java. This creates. Yeah, that's not a thing. Capital S maybe. Whatever. Whatever. Dash excellent. Recompile with. Is that not what I typed? Oh, lint, not link. Okay, you don't need to do that. That's fine. Okay. So you use javac to compile. So you pass in a Java file, and it compiles it, but it doesn't make an executable. Right? In C++, we make executables. This is green. You see that? It's got a little asterisk next to it. That means the Unix operating system, the Linux kernel, can load this and run it. Okay? If you were to look at a.out, you could decompile it, and you'd get a bunch of assembly instructions. That is the program. Java doesn't make an executable. That's the whole point. It's different. If you look at what it compiles, it creates hello world.class. And this is not an executable. It's not green. It doesn't have the little asterisk next to it. It is just a text file. Or it's a binary file. If you were to open it up, you can see that there's some you can see some of the stuff in there. And what it is, it's a special file format that is essentially a compiled Java program, but it can't run. If you tried running this, it would be like, I don't understand what you're talking about. In order to run a program in Java, you have to run it inside of Java. So you've got something called the Java virtual machine, and the Java virtual machine simulates a computer that understands the assembly language inside of hello world.class. Okay? And so you can see it prints hello world, it prints yo yo yo, prints the numbers from 1 to 9, right? And this is a program running inside of a program. And the reason why it does this is because Java is a sandbox. Ada, is there somebody at the front door? Ada? Ada? Is there somebody at the front door? Did the construction guy come? Nope. Okay. We're supposed to have somebody come to our house. So never showed up. So yeah, so this is a Java virtual machine. The reason why it does this is so that if you go out of bounds, which I'm doing here, right? Right here. You guys see this? I am accessing element 100. In C++, that would silently work, right? Which is horrible. In C++, if I did not have Address Sanitizer turned on, it would just go to that spawn in RAM and write the number 42 there, and oh Lord, help you if that's your bank account balance or your password or something important, right? This is why Java exists. Java exists because banks and things like that wanted to guarantee that you cannot go out of bounds. And if you do go out of bounds like this, it will kill your program, okay? There is no way for you to corrupt memory in Java like there is in C++. Okay, so I'm trying to access element 100, right? You guys all get why this is an out-of-bound error. It's a new array of size 100, so it goes from 0 to 99, right? You guys with me on this? Why this is out of bounds? Cool. So when I go out of bounds, then Java kills the program. It throws an exception. Index 100 is out of bounds for length 100. Tells you which line and it kills your program. Cool. All right. Neat. So anything that like Address Sanitizer would pick up, the Java virtual machine picks up. And the other really nice thing about it is that if I were to take this class file here, this hello world.class file, it'll run the same, theoretically, it'll run the same on every system that has the Java virtual machine installed. So if I have the Java virtual machine installed on my PC here, and I were to scp hello world.class over, I could run it, and it would print the exact same thing. It would print out hello world, yo yo yo, 1 to 9, exception, your thing sucks, go away, and it kills your program. Okay? So the reason why Java exists is because there was this company called Sun, which doesn't exist anymore, and they were competing with Windows. And the trouble is Windows had such big market share that nobody wanted to port their software to Sun OS, right? To their version of Unix. And so their idea was, okay, if we can get everybody writing Java, then if everybody writes their programs in Java, then we get programs that run on our operating system for free. So people might write a Java program for Windows, you know? They might write like a Dungeons and Dragons character builder in Java, which I actually have on my machine here. And, okay, cool, you made it for Windows, cool. But it's in Java. And so, because I am Sun and I want people to be using Sun, you could just be like, hey, by the way, that character builder in Java, it runs on our machine too. And so that was their long-term strategy for not dying, which was to get enough people using Java, so taking over the world through a programming language, essentially. And you get enough people using Java, and then all the programs they write for Macs and Windows just happen to run on Sun. And did it work? No. Sun is no longer with us. Bill Joy, the founder of Sun, is, you know, a rich man. I don't know if he's still alive. He's also the guy who invented VI. You know, Vim, right? Vim is by Bram Molinar, but VI, which is what Vim is based on, is Bill Joy, the founder of Sun. Oh, cool. Cool dude. Big nerd. And so at the time of the internet boom in the late 90s, early 2000s, Sun was actually a fairly going business because people were buying internet servers, and Sun OS had some pretty amazing features for servers. You could yoink a disk drive out and put a new one in, and you wouldn't even have to turn off the web server. That's pretty cool. You can actually replace a CPU, I think, and it would just keep running. Like, they had some amazing high availability stuff. I had some friends that worked on that, where you can basically just sit there with a machine running and just pull parts off and put replacement parts on, and your website wouldn't have to go down. It would maintain its uptime. Okay, so yeah, all right. So let's. I got a presentation or something on here on Java, but the good news is, pretty much the core language of C and C++ and Java and C# are all the same. For loops are all the same. If statements are all the same. And ints, pretty close to the same. There's slight hesitation in my voice there, because technically an int on C++ could be 16 bits, but not really anymore. Pretty much every int is going to be 32 bits. Java standardizes it at 32 bits. So yeah, there's a lot of different programming languages out there. There's Python and Camel and a lot of different stuff. So we can do an entire semester on just programming languages. Like it's a big topic, but I feel it's worth you guys learning Java for two reasons. First of all, get you a job. If you know Java, Java's the second biggest or third biggest. I think Python's displaced it. Language in the world. So if you know Java, you can get more jobs. Yeah, cool. It's Java. Java. Yeah. Learning Python, learning Java just makes you more employable. C++ makes you employable too. And you guys have an edge up on everyone else because most colleges don't teach C++ anymore. In fact, I tried publishing a paper saying, hey, here's a way we can make C++ easy to teach for freshmen. Right? That's a good idea, right? Like C++ has this reputation of sucking for first semester students. It's considered too hard. Everybody teaches Python and Java. But look, if you use Address Sanitizer and some other things, it's not bad. And two of the people approved the paper saying, yeah, this is great. It's a great contribution. Everybody needs to know this. The third person says, I don't think C++ should be used with first semester students. It's too hard for them. I'm like, bro. And he rejected the paper. I'm like, bro, that was the entire point of the paper. The entire point of the paper is that people have this prejudice against C++, and he's like, no, you just shouldn't be teaching C++ to freshmen. They can't get it. So you guys have a big advantage over other people, because when you transfer to another institution, you're going to have 2 years of C++ under your belt, and most people are going to have like a refresher course in C++, because they're Python people that have had like a little class, all right, this is how you do a for loop in Python, here's how you do it in C++, and they don't really know it that well. And a lot of serious programs are made in C++, and they're always sort of like awkward at C++ because they never learned it. In Java, you do new, you don't do delete, so they don't have that same mental mindset that you guys have. Every new needs a delete, right? They don't, and they just forget. They forget to delete things because they don't have to, So when you do C++ in the future, you'll have a big benefit, big advantage over other people. And I know, like, it's not bad if you teach it properly. It is possible to teach C++ to make you hate yourself and hate life and hate computer science. That was how computer science was done up until the 90s. Like, it was horrible. I completely understand why people moved away from C++ to Java, especially strings. Strings in particular, I have a particular hatred for C strings because I spent my entire second semester class wrangling with them because it was such garbage. So that's how you'd been taught before, what, in Python, Java? Or just to hate C++, yeah. So Java kind of, you have to think of Java as like C++ 2.0, right? So they took C++ and they're like, we'll make a version that is safe, and they have a nice standard library. It's a much, it's not one-to-one. Like C++ has some things in its standard library Java doesn't have, but Java kind of took everything in the 96 version of C++ and made it all object-oriented and friendly and stuff like that. And C++ definitely stole some stuff back from Java as well. You did C++ for robotics and never want to touch it again. Yeah, it's pretty normal. So C# is also like Java 2.0. So Microsoft looked at Java, said we want to do that, but we want to own it. Oracle owns Java. Oracle bought out Sun, right, and gutted it and owns Java now. Microsoft owns C#, and so C# is like Java 2.0. Or alt Java. I don't know. So, so the way that Java works, you compile it using javac, javac, Java compiler. You pass in the java.java file that gives you a class file. You run it by saying Java hello world or whatever. So it looks like this. Okay. So you compile the code using javac, you get a bytecode. It's like an assembly language for the Java virtual machine, that Java program. And then you run your program by typing Java my code, and then it runs the program. And it should run the same way on every platform. It doesn't, but it should. So it'll run the same way on Apple, Mac, Linux, 90 different versions of Unix, you know. And in fact, I mean, I had a job for a couple years porting between different versions of Unix, because there's more versions of Unix than Linux, right? Linux is a variant of Unix, the Unix operating system. It's one of many, one of 40 or 50 major, you know, different versions of Unix. And so they're all similar, but they're all different. And so they would hire me to come in and be like, okay, this is the function in SunOS, this is the function in IRIX, fix it, you know. And they need to hire Unix nerds for that kind of stuff. So, all right, so here's Hello World in Java, and we'll call it a day after this. So in Java, everything is inside of a class. And so this is not the most user-friendly thing for, like, beginners, right? It's not the most user-friendly. There's a lot of boilerplate you have to get through to get to Hello World. Python's definitely easier to get into on the first day. So class Hello World, public static void main, string array args, system.out.println hello world. So all this is boilerplate. This is the name of the class, and it also has to be the name of the file. So in Java, if you have a file called hello world.java, you have to have a class in it called hello world. The name and the file have to match, which I actually kind of like it, because you know exactly which file, you know, because in your C++ projects, you have a file called bob.cc, and inside of Bob, you have a class called Sally. And, you know, sometimes you can't, like, really remember how you organize your stuff. In Java, just the name of the file is the name of the class, and there you go. And when you import things, you know, if you import Bob or whatever, it just looks for a file with that name. You know, it's pretty easy. You don't have to do all the, you know, hashtag, include, copy, paste nonsense. You just import, and then it finds the file because it knows where it is, because there's a directory structure that matches the everything, and it just finds it automatically. It's nice. So the Java include system is definitely better than C++'s. It is more verbose, though. Java is a very verbose language. They love making you type things. That's definitely part of the experience, is you just type a lot more to do Java. Okay, so we'll just call it here. We'll pick up our conversation with Java next week. We'll probably finish off Java on Monday, maybe Wednesday. We'll see how that goes. And then if you have any topics that you want to learn about for maybe Wednesday, maybe Friday, we can do that. Just have some fun. It's not going to be graded or anything. Okay. Java, I'll probably give you a Java programming assignment. It's pretty easy. But probably on Monday I'll give you a Java programming assignment. But the rest of the topics that we talk about is just for fun. It's for your edification. Can you enter a file for the histogram to visualize it? Enter a file for the histogram to visualize it. Isn't that in there already? Yeah, enter the name of the file to open. Yeah, so. Like when you run it, you're going to pass in, like, public, Shakespeare, tragedies, Hamlet, something like that. So in the public Shakespeare directory, there's various files, various directories with different stuff in it. Poetry, sonnets. Then let not winter's ragged hand deface in thee thy summer, ere thou be distilled. Make sweet some vile, treasure thou some place with beauty's treasure ere it be self-killed. That use is not forbidden usury, which happies those that pay the willing loan. That's for thyself to breed another thee, or 10 times happier, be it 10 for 1. 10 times thyself were happier than thou art, if 10 of thine 10 times refigured thee. Then what could death do if thou shouldst depart, leaving thee living in posterity? Be not self-willed, for thou art much too fair to be death's conquest, and make worms for thine hair. Ooh, that's a little dark. All right, yeah. So C++ is it the best language? It's a language. It's kind of my go-to for game development and anything that needs performance. Yeah, and just in general, it's just a good general purpose language. Yeah. So, but if you know C++ and you know Java and you know Python, then that's going to, and C is technically a different language, then that'll cover most jobs. C# maybe also. That'll cover most jobs these days, so you can get a job at any of them. What happens is that when you do computer science for a while, you kind of learn they're all kind of, kind of the same. Like when you know how to program, like you're just like, okay, this is how you do it in C++. This is how you do it in Python. Okay, yeah. It's a little different. Same concept. It's not actually that big a deal. You know what I mean? Like you just kind of, if you need to learn a new language, you just kind of sit down for a week and play with it. And you're like, oh, okay, I got it now. It's not actually, it doesn't take you a year. Like it takes you a year to learn C++. It's not like the next one's going to be a year. It's like a week. Yeah, computer science is really about the mental processes and learning to think through problems and learning to debug and systematically find out why your code isn't working and where it's gone wrong and what you should do to fix it. That's why computer science is a 4-year degree, because it takes a while to build up your mental skills. But the actual language itself, yeah, after a while, it's a week's effort to learn a new language. Okay. So yeah, if you want to learn Go, like you can just go through a tutorial. Like, okay, I got it. Learn Objective-C, Swift, whatever. Not a big deal. It's really not a big deal. It seems like a big deal when you're a freshman, but it's just because you're learning everything all at once. Later on, like I took a programming class, a programming languages class. Every week it was a new programming language. 10-week class, 10 programming languages. And you had to write a program. You had to do like calculus. You had to like write an integral solver in every Pascal and ML and Perl and who knows what else. So, all right. So that's it for today, guys. Have a great Thanksgiving. We're gonna be doing games on Friday from 12 to 4. It's not extra credit. Just come hang out if you want to have a good time on Black Friday. Not do some shopping, play some Jackbox, things like that. And yeah, we'll meet up last week of school next week. Peace out. Ooh, Steam sale. Nice. All right, see you guys.